folks. Here we are again. Welcome to another episode of Wisdom Bird Talks Tech. I'm your girl from the Northeast, your chatterbox but tech-savvy host, Wisdom Bird. If I'm not online, I'm anxious like my phone's running out of battery. Welcome, future AWS machine learning engineers. Today we're diving deep into the world of AWS ML services to prepare you for the MLA-C01 exam. This certification validates your ability to implement, deploy, and manage machine learning solutions on AWS, focusing on practical skills that data engineers, data scientists, and ML engineers need in the real world. What makes this exam unique? The MLA-C01 exam consists of 65 questions to complete in 170 minutes, with a passing score of 720 out of 1,000. Unlike theoretical exams, this certification demands hands-on experience. You need to know how to actually build, deploy, and optimize ML workflows. AWS Elastic MapReduce EMR, the big data powerhouse, understanding EMR architecture. EMR is your Swiss Army knife for big data processing on AWS. Think of it as a managed Hadoop ecosystem that takes the complexity out of distributed computing. The beauty of EMR lies in its cluster architecture. Master node, the conductor of your orchestra, manages the cluster and coordinates tasks. It's always a single EC2 instance that you can't lose without losing your cluster. Core nodes, the workhorses that store HDFS data and execute tasks. You can scale these, but be careful. Removing them risks data loss. Task nodes, the flexible workers that execute tasks without storing data. Perfect for spot instances, since losing them won't affect your data integrity. Exam tip, remember the task node spot strategy. Always use spot instances for task nodes to save costs, but never for core nodes where you store critical data. EMR integration ecosystem. EMR doesn't work in isolation. It's deeply integrated with the AWS ecosystem. S3, your primary data lake for input-output. CloudWatch, real-time monitoring and alerting. IAM, fine-grained access control. VPC, network isolation and security. CloudTrail, comprehensive auditing. Storage options decoded. EMR offers multiple storage paradigms. HDFS, traditional Hadoop distributed file system. EMRFS, the game changer that lets you treat S3 like HDFS with optional DynamoDB consistency. Local storage, fast but ephemeral. EBS, persistent block storage for HDFS exam focus. EMRFS with consistent view using DynamoDB is crucial for exam scenarios involving data consistency requirements. EMR Serverless, the future of big data processing. Revolutionary serverless architecture. EMR Serverless represents a paradigm shift. You simply choose your EMR release and runtime, Spark, Hive, Presto, submit job requests, and AWS automatically scales nodes based on demand. No more capacity planning nightmares. Key advantages. EMR Serverless automatically scales resources up and down in seconds, providing just the right amount of capacity for your application, while you pay only for what you use. This eliminates the traditional challenges of over-provisioning and under-provisioning. Application lifecycle management. Applications progress through distinct states: creating, starting, stopping, terminated. Understanding these states is crucial for cost optimization. API operations. You must know. Create application. Initialize your serverless environment. Start application. Begin processing. Charges start here. Stop application. Pause to avoid charge. Delete application. Clean up completely. Cost optimization tip. Configure pre-initialized capacity to keep workers warm for immediate job execution. But remember, charges apply when workers are initialized. Security and networking. EMR Serverless now supports private and public subnets, offering cost-effective outbound data transfer options. Each application runs in its own secure VPC environment, completely isolated from other applications. Exam scenario. You're asked to optimize costs for intermittent big data jobs with varying compute requirements. EMR Serverless is your answer. Automatic scaling with per-second billing. Apache Spark and MLLib, machine learning at scale. Spark architecture fundamentals. Spark operates on a driver-executor model. Driver program contains the Spark context and orchestrates the entire application. Executors, distributed workers that execute tasks and cache data. Cluster manager, coordinates resource allocation, can be Spark standalone, Yarn, or Kubernetes. MLLib, your machine learning arsenal. Spark's MLLib provides production-ready algorithms. classification algorithms, logistic regression. For binary and multi-class problems, naive Bayes, excellent for text classification, decision trees, interpretable and handles mixed data types. Regression and advanced techniques, linear regression for continuous predictions, random forest for ensemble learning, recommendation engines using alternating least squares, clustering and dimensionality reduction, k-means clustering, for customer segmentation, principal component analysis, PCA, for feature reduction, latent dirichlet allocation, LDA, for topic modeling. Practical application. MLLib's pipeline API allows you to chain transformations and estimators, creating reproducible ML workflows that can be versioned and deployed consistently. Interactive development tools. Zeppelin versus EMR notebooks. Zeppelin, community-driven, great for collaborative analysis. EMR notebooks, AWS integrated, automatic S3 backup, seamless cluster provisioning. Exam strategy. Questions about interactive ML development typically favor EMR notebooks due to tighter AWS integration. Feature engineering, the art of machine learning. The foundation of ML success. Feature engineering is often called the art of machine learning because it requires domain expertise to transform raw data into meaningful signals. Remember, garbage in, garbage out. Great features make great models. Text processing mastery. TF-IDF, term frequency inverse document frequency. This technique measures word importance by balancing frequency within a document against rarity across the corpus. Extensions include unigrams, single words, bigrams, two-word phrases, trigrams, three-word sequences. Real-world application. Search engines use TF-IDF to rank document relevance. High-frequency terms in a document that are rare globally indicate strong relevance. Handling missing data strategically. Imputation hierarchy, from basic to advanced. Mean, median replacement, quick but often inaccurate. Prefer median for outlier-heavy data. Deletion, only suitable when missing data is minimal and random. K-nearest neighbors, KNN, averages values from similar records. Machine learning imputation, builds models to predict missing values. MICE, multiple imputation by chained equations. Advanced iterative approach. Collect more data, often the best solution when feasible. Exam insight. Questions will often present scenarios where you need to choose the appropriate imputation method based on data characteristics and business constraints. Balancing datasets, solutions. Oversampling, duplicate minority class samples, simple but effective. Undersampling, remove majority class samples, use cautiously. SMOTE, synthetically generate new minority samples using nearest neighbors. Threshold adjustment, modify classification thresholds to optimize for specific metrics. Advanced pre-processing techniques, outlier detection and treatment. AWS's random cut forest algorithm is specifically designed for outlier detection and is integrated into QuickSight, Kinesis Analytics, and SageMaker. Data transformation methods. Binning, convert continuous variables to ordinal categories. Scaling normalization, ensure features have comparable ranges. Encoding, transform categorical data, one-hot encoding for neural networks. Log transformation, handles skewed distributions and super sublinear relationships. Pro tip, always shuffle your training data to prevent algorithms from learning spurious patterns based on data collection order. Amazon's SageMaker, the complete ML platform. SageMaker ecosystem overview. SageMaker orchestrates the entire ML lifecycle from data preparation to model deployment. Think of it as your ML assembly line with specialized stations for each phase. AI domains and infrastructure. SageMaker AI domains organize users, applications, and resources while sharing an EFS volume. 2 VPC options. SageMaker Managed VPC. Quick setup with internet access. Custom VPC. Enhanced security with encrypted traffic routing. Data preparation pipeline. Data sources and integration. S3 for scalable storage. Athena for serverless queries. EMR for big data processing. Redshift for data warehouse analytics. Key spaces for NoSQL requirements. Processing capabilities. SageMaker processing jobs create a powerful ETL pipeline. Copy data from S3, spin up containers, built-in or custom, execute transformation logic, output process data back to S3. Training infrastructure, training job components. S3 input-output locations, compute resource specifications, ECR path to training code, hyperparameter configurations. Algorithm options. Built-in algorithms optimized for AWS infrastructure. Popular frameworks, TensorFlow, PyTorch, scikit-learn, XGBoost. Custom Docker containers, AWS Marketplace algorithms. Deployment strategies, real-time inference, persistent endpoints for low-latency predictions with automatic scaling capabilities. Batch processing. SageMaker Batch Transform processes entire datasets efficiently without maintaining persistent infrastructure. Advanced deployment features, inference pipelines, chain multiple models for complex workflows. SageMaker Neo, optimize models for edge devices. Elastic inference, attach GPU acceleration only when needed. Shadow testing, A/B test new models against production models. Cost optimization, use spot instances for training jobs that can handle interruptions, savings of up to 90% on compute costs. SageMaker Ground Truth, democratizing data labeling, human-in-the-loop labeling. Ground Truth revolutionizes data labeling by creating its own learning model as humans label data. The intelligent insight, send only ambiguous cases to human labelers, while the ML model handles obvious cases. Efficiency gains. This approach can reduce labeling costs by up to 40% while maintaining quality. Workforce options. 3-tier labeling strategy. Amazon Mechanical Turk, public crowdsourcing for simple tasks. Internal teams, domain experts for specialized requirements. Professional labeling companies for compliance and quality guarantees. Ground Truth Plus, the managed service. Ground Truth Plus provides a turnkey solution where AWS experts manage the entire workflow, including workforce selection, training, and quality assurance. Perfect for organizations without internal labeling expertise. Exam scenario. When presented with questions about scaling data labeling operations, consider Ground Truth Plus for turnkey solutions and standard Ground Truth for custom workflows. Alternative labeling strategies? Automated labeling options. Amazon Recognition for image classification. Amazon Comprehend for text analysis and sentiment. Pre-trained models for bootstrapping datasets. Unsupervised techniques for initial clustering. SageMaker Data Wrangler, visual data preparation. No-code data transformation. Data Wrangler provides a visual interface within SageMaker Studio with over 300 built-in transformations. The power lies in accessibility. Data scientists can focus on insights rather than coding transformations. Key capabilities. Transformation arsenal, image manipulation, resize, enhance, corruption for augmentation. Data balancing, oversampling, undersampling, SMOTE implementation. Missing data imputation with multiple strategies. Outlier detection and treatment. Dimensionality reduction using PCA. Custom integration. Support for pandas, PySpark, and PySpark SQL allows custom transformations when built-in options aren't sufficient. Quick Model feature. The Quick Model capability lets you rapidly prototype and evaluate different algorithms, providing immediate feedback on data preparation quality. Practical workflow. Import data, visualize distributions, apply transformations, quick model validation, export to full training pipeline. Model monitoring and bias detection. SageMaker Model Monitor. Model Monitor provides automated quality assurance for deployed models through CloudWatch integration. Think of it as your ML canary in the coal mine, detecting when models drift or degrade. Monitoring capabilities. Data drift detection, input data changing over time, model quality degradation, anomaly detection and prediction patterns. Feature importance shifts. SageMaker Clarify integration, bias detection framework. Clarify integrates with Model Monitor to detect bias across demographic groups. This is crucial for responsible AI deployment. Pre-training bias metrics. Class imbalance, CI, measures representation balance. Difference in proportions of labels, DPL, compares positive outcome rates. Kullback-Leibler divergence, KL, statistical distance between distributions. Jensen-Shannon divergence, symmetric version of KL divergence. Conditional demographic disparity, CDD, measures fairness within subgroups. Explainability features. Clarify identifies which features contribute most to predictions, enabling both bias detection and model interpretability. Exam Alert Questions about responsible AI and bias detection increasingly appear on AWS ML exams. Understand when to use Clarify for both bias detection and explainability. Advanced topics and exam strategy, cost optimization strategies. Training cost reduction, use spot instances, up to 90% savings. Implement early stopping to prevent overtraining. Use managed training features to optimize resource utilization. Inference cost management, auto-scaling endpoints based on traffic patterns. Multi-model endpoints for serving multiple models on single infrastructure. Batch transform for large-scale, non-real-time inference. Security best practices. Data encryption. S3 encryption at rest, SSE S3, SSE KMS or CSE. TLS in transit between all AWS services. VPC endpoints for private connectivity. IAM roles with least privilege principles. Performance optimization. Training acceleration. Distributed training for large datasets. Pipe mode for streaming large datasets from S3. SageMaker debugger for identifying bottlenecks. Hyperparameter tuning jobs for automated optimization. Exam success strategies, question pattern recognition. Scenario-based questions. The MLA-C01 exam heavily features real-world scenarios. Look for keywords. Cost-effective. Consider serverless options. EMR Serverless, SageMaker. Real-time. Think endpoints and streaming services. Large scale, EMR, distributed training. Compliance, VPC, encryption, IAM policies. Time management. 170 minutes for 65 questions means approximately 2.6 minutes per question. Don't get stuck on complex scenarios. Mark for review and return. Common pitfalls to avoid. Over-engineering solutions. Choose the simplest AWS service that meets requirements, ignoring cost implications. Always consider the most cost-effective option when multiple solutions work. Mixing up EMR deployment options. Understand when to use EMR on EC2 versus EMR Serverless versus EMR on EKS. Confusing Ground Truth options. Know when to recommend Ground Truth versus Ground Truth Plus. Final preparation checklist. Hands-on experience requirements. Deploy an EMR cluster and run Spark jobs. Create SageMaker training jobs with different algorithms. Set up model monitoring and understand CloudWatch metrics. Practice with SageMaker Data Wrangler. Implement a complete ML pipeline from data prep to deployment. Study focus areas. The exam domains and their weights are: data preparation for ML, 28 cent, highest weight. Model training, 26 cent. Model deployment and inference, 24 ML operations and ML ops, 22%. Conclusion, your path forward. The AWS MLA-C01 certification validates practical skills that directly translate to real-world ML engineering success. Remember, this isn't just about passing an exam. You're building expertise in the world's leading cloud ML platform. As demand for AI and ML specialists is expected to grow by more than 80% by 2030, this certification positions you at the forefront of a transformative field. Final success formula: hands-on practice with every service covered. Understand the why behind each AWS service design. Think like an ML engineer. Focus on practical, cost-effective solutions. Practice with real exam scenarios using multiple question banks. Good luck, and welcome to the future of machine learning engineering on AWS. All right, folks, that's it for today. If you enjoy Wisdom Bird Talks Tech, don't forget to like, bookmark, and share. Your triple support is the biggest motivation for Wisdom Bird to keep going. Got a tech topic you want to hear about? Drop it in the comments. Wisdom Bird will cover it next time. See you in the next episode, where we'll keep chatting tech, talking people, and exploring the human warmth behind AI. I'm Wisdom Bird, the super smart bird flying with you on this tech journey.